Turns out a couple of you came up with some slightly modified or slightly, I think, simpler ways of doing this problem. For me, I'm just looking at my denominators here. I see a 2, a 3, and a 6, and not trying to simplify this problem first. If I look at those, I know that if I multiply both sides of this by the number 6, this will bust up all the fractions. So that's what I'm doing. And some of you did something slightly different, and you end up getting the correct answer as well. So that's great. So I'm going to go ahead and do this. I've got to distribute this 6 to two different terms on the left-hand side. When I do that, I end up with 6 times and then my 6x that was in the numerator over 2. And then I've got plus 6 times 4 rather, over 3. And then on the other side, that's going to equal, I'll just put 6 times 2x, and then that's over the number 6. So where'd the simplification happen? Well, look, right? I guess on the right-hand side, I've got a giant 1, right, in the 6 divided by 6. So this just becomes 2x. When I take 6 divided by 3, right, if I'm thinking about this, 6 divided by 3, that equals the number 2. And 2 times 4 is 8. If you don't see that right away, you could just go ahead and say, hey, well, 6 times 4 is 24, and 24 divided by 3 is 8, so that works as well. And then finally, I've got, either I'm going to 6 divided by 2 is 3, 3 times 6 is 18, or 6 times 6 is 36, and 36 divided by 2 is 18. But either way, I end up getting exactly 18 x here. So I've got 18x plus 8, and that equals 2x. Equals 2x. Now I'm going to take away 2x from each side. And when I do that, I'm very careful. This is always a place where, bad things can happen. But as I take away 2x from both sides, I'm cognizant of the fact that I now have a side that has nothing on it. So I put that 0 symbol there to make sure I keep track of that. So my right-hand side is now nothing. On my left-hand side, I've got 18x minus 2x, which is 16x, and then plus 8. I'm going to subtract 8 from both sides, so I get 16x is a negative 8, and then I'm going to divide both sides by 16. So x is negative 8 over 16, and if I simplify that, x is, I believe, negative 1/2. So this is what I think x is. One of the points on this problem was to show a check to make sure that your solution worked. So in the check, what I'm doing is I'm just basically copying the original problem, but every single place where there's an x, I'm going to replace it with this negative 1/2. So if I look at it on the left, there's two sides of the check, right? So on the right-hand side, I've got 6 times 1/2 over 2, and then plus the number 4/3. And on the other side, we're trying to see if these are equal, I've got 2 times negative 1/2, and I'm going to divide that by the number 6. So let's see. Let's look at the left-hand side. 6 divided by 2 is 3. So I think this becomes 3 times negative 1/2, which is negative 3/2 plus 4/3. And on the other side, what do we have? Yuck. Well, if I multiply that numerator times 2, if I multiply this 2 times the negative 1/2, this becomes a negative 1. So I end up getting negative 1/6 here. So the question is negative 2/3, or is negative 3/2 plus 4/3 really the number negative 1/6? And you can grab a calculator if you want to check this, but I'm going to go old school. I'm going to multiply this first fraction by 3 over 3. And I'm going to multiply this second fraction by 2 over 2 to get common denominators. Let's see, negative 3 times negative 3 is negative 9 over 6 plus, that would be 8 over 6. And if I combine those, it is exactly negative 1/6. So I can see that, yes, indeed, when I plug that in, I do get negative 1/6 on both the left and the right hand side. Now, if you were to just write this down and then go to the decimal approximation your calculator gave you, that would be fine. I just want to see something that indicates that you understand and that you checked that your value of x really does make the left and the right hand side the same. So the answer here again is x is -1/2. Next problem. Poor Candace. She has this puppy. Reminds me of Finn, my dog at home. Every single time I get home, I take my shoes off by the door, and Finn loves to grab my shoes and chew on them. They're a chew toy. He hasn't grabbed my homework, though. Candace is doing her homework when her dog bit off a piece of the paper. All she had left of the sequence was terms 1 and 5. So she's got the first and the fifth term in a sequence. And the question is, could that sequence be arithmetic if you just have the two values there? Well, yeah, it actually could. If you look at those two numbers, I'm starting at 3 and ending at 42. Well, 42 minus 3 is the number 39. So I know I need to go up by a value of 39, and I need to do so in 1, 2, 3, 4 steps. So I'm just going to take this 39 and I'm going to divide it into 4 equal pieces. And when I do that, I get the number 9.75. So I believe, I've checked it, if you start with 3 and add 9.75 and then keep doing that again and again and again, it will end up with the very last value being 42. In fact, let me jump down to this part C. So if I fill it in, 3 plus 9.75 is 12.75. And then I'm going to add another 9.75, and it'll give me 19.5. Plus 9.75 is 32 1/4. And 32 1/4 plus 9 3/4 is exactly the number 42. So this grows exactly correctly, right? We're growing by 9.75 each time. So it says, could this sequence be arithmetic? Yes. And the other way to think about this is, if you look at it, think about this as an ordered pair. When x is 1, y is 3. When x is 5, right, y is 42. So if you look at that, you could calculate the slope. Turns out the slope for those 2 points would be 9.75. So every single time we're adding 9.75 as x increases by 1. And then finally it says, what's the equation of this sequence? Well, we know that we've got repeated addition. We keep adding 9.75. So part of it is going to be y equals 9.75 times x. But we also need our 0th term, right, to adjust for the fact that the first term is not the 0th term. So what I would do is I would take the first term, 3, and I would subtract 9.75. And when I do that, I get negative 6.75. So this is my 0 term. So I would just say, minus 6.75. And if you were to take these 2 points, you found the slope. Then if you were to calculate the y-intercept for them, you would get negative 6.75 as well. So that's your equation, y equals 9.75x minus 6.75.